All right, here's another example. Again, solving by substitution, so I'll have them written side by side. In my mind, it looks easier to solve this equation for x. I'm just going to add 2y to both sides. So x equals 2y plus 3. Now I'm going to take this and substitute it over here for x. So 2 times 2y plus 3 minus 4y equals 9. And now I have one equation, and the only unknown is y. So I'm going to try and solve this for y. So distributing the 2. And then when I go to clean this up a little bit, something weird happens. When I go to clean this up, the y's disappear. And what I'm left with is just 6 equals 9. Okay, that's a problem. Because, well, two things. First of all, I don't have a variable. It's gone. And then the second problem is I am left with something that doesn't even make sense. 6 does not equal 9. So when that happens, when you are working your substitution problem or elimination problem, it happens there as well. But when you're working your problem and the variables cancel out and you are left with something that is not true, you are actually done solving the problem. The answer to the problem is no solution. What that means is graphically, if you graph this line and you graph that line, those lines are parallel. They do not intersect. They have no points in common. What this means is there is no value for x and y that will work in this equation and this equation. So when you are solving and your variables cancel out and what you're left with is nonsense, something that's untrue, your answer is always no solution.